Hello everyone, I'm Atif Ali Khan. I will be your lab instructor for the experiment number 01, which is investigation of the fire suppression mechanism of a water mist nozzle. What is water mist suppression system? These systems are designed to suppress any pool fire or any fire which historically was done by halogenated systems. But halogenated systems are obsolete because of their environmental issues, especially because of their ozone depletion potentials. So these water mist nozzles are used as a suppression agent, where water will be as a suppression agent. So this is the water mist nozzles, which is usually installed in where you want to suppress a fire. So here you see they have a mesh where the water comes very small droplets, and the orifice size is quite small here, where water will come very small size, and after deflector it will change, the droplet size becomes like 500 times smaller. And this droplet size is because of the exceptional properties of water. It can, because of evaporation, it can cool the temperature inside the compartment, as well as it can suppress the fire. So this is water mist nozzle, and I want you to compare it with the standard sprinklers. So these are the standard sprinklers which is used in your office rooms and buildings. You will find these sprinklers. So but this system, these sprinklers is basically used for fire controlling the fire, not to suppress. But water mist nozzle is designed to suppress the fire. So you can see the difference here. Mainly is you can see the orifice size here, which is quite small in comparison to standard sprinklers, which makes a huge difference when the water will come from this orifice, and with the very high pressure, it will be like more than 10 bar. When this pressure, when it will come from this high pressure, the force coming from this orifice will convert all these water droplets in a very minute sizes, and water will come as a mist, and it can cool down the fire within the compartment. Okay, this complete panel is known as a fire pump controller. In case of the water mist systems, it is necessary to have a fire pump, because you need a very high pressure to, as I discussed previously, that you need a very high pressure to convert the water in a very minute water droplet. So you need a pump, and you require very high pressure, which will be possible by using this fire pump controller, which will control your pump. So you can start the pump from here, and from this you can control the speed, at what speed you need fire pump. So this is a pressure gauge where you see the reading of the pressure which is required. In this experiment we will be using 13 bar, so which is a very high pressure again to produce water mist. So this pressure gauge is basically only for water mist system. This control panel where you can start your water mist system by clicking this button. So basically it will start the water mist system inside the fire chamber, because we have another system installed in this fire chamber, like sprinkler system for testing. So this is the first one we will use for water mist systems. This is a thermocouple tree where you will measure the temperature which is produced during the fire. So each thermocouple is at equidistance of 30 centimeter up to the height of 2.4 meter. So you can measure this temperature along this in vertical direction using this. This is water mist nozzle which is installed on the ceiling, so which we will be using for an experiment. First we will calculate the water discharge without using any fire, and see how much water is discharged from the nozzle, and we will check the pattern of the water discharge from this nozzle. Yes. 1, 2, 3. we are going to measure the temperature on the thermocouple, which I already showed you earlier. So from this data logger, we will measure all temperatures which are received on this thermocouple. So once the fire will start, we will start here and start recording the temperatures which is achieved. So firstly we will start the fire and we will measure the temperatures, and the second time we will measure the temperature and checking the water temperature reduction when the water mist system is started. So here this is a thermocouple. As I told earlier, this we measure the temperature, and here we are taking the 200 ml of propanol, which we will burn and then take the temperature from this thermocouple sheet, how the temperature reached earlier, and how we will initiate the fire. We will ignite with this electric igniter. So you can see that how it will ignite. You can by electric. And this igniter will be used either with the propanol and the fire will start. So let's begin with this experiment 1. So during this time we will measure the temperatures from the data logger which I showed you earlier. How's your things going on?
Is it recording?
So in this part of the experiment, what we're going to do, we use again the 200 ml of propanol and we ignite and we measure the temperature using the thermocouple tree again. But this time, after 1 minute of fire starting, we'll start the fire water mist systems and we will measure how the temperatures rise. Okay.
You understand what we are doing?
You are masters in fire engineering.
No. I'm just a master student.
You're master. You finished master. So you're master already.
I finished master. Okay. So we can finish.
Yeah.